Okay, today we are going to go over our math packet number 10. We're not going to go through the answers, just going through ways to solve, little tips on how to solve the different pages. So let's look at our first page. Alexis and Vinny drove to Philadelphia for the weekend. How fun. They decided to see some of the landmarks and needed a place to park for 3.5 hours. They see two signs advertising two different parking lots and go with the cheaper total cost. How much do they pay to park? So you're going to have to go through and you're going to have to look at how much would they pay to park at Pat's Parking if the first hour is $8 and then they do 60 cents for every half hour after that. So you need to figure out you've got 1 hour out of the 3.5 hours would be $8. Then you have 2.5 hours left. What do we want to do with that 2.5 hours if we know there's a price for every half hour, Sam?
You would divide it by 5, so divide it by half.
Yeah, you'd break them into the halves, so you know how many halves you need. So you have to break that 2.5 hours that's left over into their halves, so you know how many halves to add on to the $8. Same thing for Paul's parking. They have the first hour and then half hour increments after. So you're going to have to figure out which one is the better deal. If they go with the cheaper one, how much do they pay? A train leaves a train station at 1 p.m. It travels an average rate of 60 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 96 miles per hour. The second train follows the same route as the first train on a track parallel to the first. In how many hours will the second train catch up with the first train? I've been telling people as we've been going through the week that you can leave it at a whole hour. You don't need to break it into minutes because the question is in how many hours. So you're going to round it to that nearest whole hour. So if you're starting at 1 p.m., you know that first train leaves. So at 2 p.m., if he's going, how far is he going to make it in 1 hour? So at 2 p.m., how far will he be, Sam?
He would be at
First train.
First train.
He left at 1, and he goes 1 hour. So he's gone 60 miles, right? Because it takes a whole hour to get 60 miles out. He goes 60 miles per hour. So at 3 p.m., he would be another 60 miles away from there. Our second train leaves at 2 p.m. He leaves an hour later, and he's going at 3 p.m. How far would he have gone if he was traveling 96 miles per hour? Owen, how far would he go in 1 hour?
96 miles.
So he would have gone 96 miles. So make sure you're lining them up correctly. They don't leave at the same time. They're leaving at different times. How far does this one go? How far is he at 4 p.m.? How far is he at 5 p.m.? See when that second train overtakes the first train. How many hours has he been going till he overtakes that first train? So your answer should not be a time. I don't want to know what time he overtakes the first train. I want to know how many hours it's taken him to get there. 5-card challenge, we know. Common question people have been asking because we have an ace. Aces are a wonderful thing. Multiplication is one operation. Division is a different operation. Multiplying and dividing by 1 really gives you an easy, let me build up my numbers, see how many points I can get. I can get a whole lot of easy points if I have a set of operations and then I multiply it by 1. It counts as a new set of equations. So multiplying 1, dividing by 1, it counts as a new set of operations, new set of equations. easy way to try to get much higher than the 15 points that we need. If you're doing the easy way out and you're doing that, I found a way of doing it with 3 numbers, and I didn't use that 1 yet, so I'm going to multiply it by 1 now, and now I use 4 numbers. Yeah, you can do it, and I'll accept it, but I challenge you to bump up your numbers. That I challenge you to try to get to the geometry 21 points. If you're going to take the easy way out, doing multiplying by 1, dividing by 1 to bump up your number score, then find more. Okay? Challenge yourself. That's how we learn and grow. Taking the easy way out, we're not learning and growing. It's not going to help us on the math test. Not going to help grow our brain muscle. Don't take the easy way out if you don't have to. Okay? Really try to go a bit above and beyond. You can do it. Find the area of the entire figure and the shaded region. All work must be shown. So, finding the area of the whole figure is easy. What is the formula to find the area of our rectangle? Leah? Length times width. Find the area of the rectangle. That's an easy one for us. Now we want to find the area of the shaded. What do you think I need to do to find the area of the shaded? Ryan?
Find the area of the rectangle and then subtract it by the rectangle.
You said rectangle twice. Find the area. We already found the area of the rectangle. So what do we want to find the area?
The triangle.
The white triangle. So we want to find that area of the white. It's a triangle. How do I find the area of a triangle? Leah?
Length times width divided by 2.
Length times width divided by 2. So 1/2 times length times width. Length times width divided by 2. That'll give us the area of our triangle. So instead of saying length times width, we could say base times the height, right? Base times height. Think about where our base of our triangle is. Think about that height of the triangle. So 1/2 of the base times the height. So then what do I have to do to find my shaded area? Maddie? Subtract them. Subtract the white away, and you're left with just the shaded. All right, for our formula or our pattern page, we need to complete the table up to the 9th figure. So we need to find our patterns. In order to find the patterns, we need to fill in the missing numbers. So let's fill in for our figures 1, 2, 3, 4, and 5, and see if we can start seeing those patterns. How many yellows in the first figure?
1.
How many in the second figure?
1.
How many in the third?
1.
How many in the fourth?
1.
How many in the fifth?
36. 33.
33. How many pinks in the first one?
0.
How many in the second?
8.
Third?
8.
Fourth?
8.
Fifth?
8.
How many blues in the first?
0.
How many in the second?
0.
Third?
16.
Fourth?
16.
Fifth?
16.
How many red in the first?
0.
Second?
0.
Third?
0.
Fourth?
24.
Fifth?
24.
How many total in the first?
1.
Second?
9.
Third?
45.
Fourth?
49.
Fifth?
81.
So when we look at finding those totals, we know that these are squares. So 1 times 1 for my first gets us a total of 1. Our second, we have 1, 2, 3 times 3 gets us 9. Here we have 1, 2, 3, 4, 5 times 5 gets us 25. 1, 2, 3, 4, 5, 6, 7 times 7 gets us our 49. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9. What do we know about these numbers?
They're your favorite numbers.
They're my favorite numbers. Perfect squares. What kind of pattern do we have with our perfect squares, Paisley? They're all odd numbers. So if we know what our pattern is for our totals, can we fill in the totals for that whole box, for that whole column? Yeah, because we can follow that pattern. 1 squared, 3 squared, 5 squared, 7 squared, 9 squared. What would this one be? 11 squared. What is 11 squared?
121.
121. All right, so let's see what else we can just fill in by seeing our patterns. How many times do we have the same number in a row? Caitlin? 4. We have 1, 1, 1, 1. And then we have 33. Well, what's going to be our 6?
33.
What's going to be our 7?
33.
What's going to be our 8?
33.
Do we know right now what our 9th is going to be?
97.
No. Excuse me. We're not just shouting out answers if we haven't done the work to find them. We can follow patterns, but we're not just randomly shouting out any answers. Okay? Only following patterns right now. People can figure out answers themselves. Can we go on with the pink? No, because we don't know the pattern yet. Can we go on with the blue?
Yeah.
Yeah, because we only have 3 16s. How many more 16s can I put?
1.
Can we go on with the reds?
Yes.
Yep. How many more can I do?
2.
Yep. We know that we can go on with all of our totals because we found that pattern. If we know our total and we know the red and the blue and the yellow, can we figure out what the pink is?
Yeah.
How? Colin?
You subtract the ones that you know from the total.
Yeah, we subtract to the colors that we know from our total. So if we subtract out the yellow, the blue, and the red from our 121, we're going to be left with our pink. Then if we know our pink, can we fill in for the next 4? Yeah. Then if we have that pink filled in, can we solve for the blue? Yeah. Follow your patterns. Okay, follow the patterns. You only have to go to the 9th figure. Do you think you could challenge yourself to fill in the whole table? Just keep following your patterns, and you can get that whole table filled in. All right, let's look at our next one, our triangular prism. First things first, you need to draw a net and label its sides. This is one that I went a little too fast on myself when I was doing my answer key, and somebody else pointed out to me my mistake. It's easy to make mistakes. So be careful when you're doing your labeling. What should my net look like? How many rectangles? I know there's a rectangular base, so I'll start with that. How many rectangles do I need? 3, because there's 3 faces. So I'm going to need 3 rectangles. What else do I need to put on there, Nathan? I've got triangle faces on each end. So I have those 2 triangle faces. If I lay it out flat, I'm going to have triangles on my end. So then I need to put my numbers on there. I know the height of the triangle is 8. That's going to help me when I'm finding the area of those triangles. I know that underneath the triangle is a 12. And I know the side of the triangle is 10. Right? Do I know anything else?
Well, you have to find the lines.
So we also know, I do know something else. I know my total volume is 960. So if I know my volume of the triangular prism is 960 inches, what key piece of information do I need to solve for in order to find, I can find the area of my triangles with the information they gave us straight up. Because I know a triangle is that 1/2 base times the height. But I need to find the area of my rectangle. How do I do that? Nathan?
You have to find for X.
I have to find for the X. How do I do that, Nathan?
I times that volume by 2 because and then I times all the other ones up. Because if you times it by 2, that's what it's going to come out to because you have to divide it by 2.
If I multiply 960 by 2, that would give me the volume of a full rectangle. But that's still not giving me that. So I'm not quite following the way that you did it. Izzy, what do you think?
You do 8 times 12 times 10 divided by 2.
That's just the triangle. So you don't need the 10 when you're doing the triangle, right, Izzy? You need base times the height. So our base times height divided by 2. So base times height. That's what we want for a triangle. Joseph, what do you think?
How to find for X?
Yeah.
Since 10 is like half of the size of the base, we'll multiply 10 by 2. Oh,
We have no idea if this 10 is half of the X.
okay.
That's something that's not information they gave us, so we can't assume it just by looking at it and saying, well, it looks to be about half. We don't know that. So if we don't know it, we can't do it. Colin, what do you think?
If you take the volume for 960 inches cubed or cubic inches, I think you can divide it by.
So before we divide it, what is our formula for volume? It's a triangular prism, so 1/2 length times width times height. So our length, is that length or width? Really doesn't matter. We'll put it as that's going to be our X. So let's fill in the numbers that we know. 1/2 X times 12 times our height. Uh-oh. What did I just do? Times our height. And then we solve it for X. That's not a 0.8, that's a multiply by 8. So 12.
Hold on.
Well, times 8. So if we're going to solve for X, we need to multiply by that 2, divide by the 12, divide by the 8. And then we're left with the X. Once we know X, do we know another piece of information that we could have filled in on our map?
Yeah.
Caitlin.
The other rectangles, those other sides, we know are 10.
Oh, this right here that we knew was 10 right here, we know that connects to right here. So that is a 10 for the rectangle. It's a 10 for the triangle. It's also a 10 for the rectangle. So we know that their ends over here are 10s. So that was information that we could have put onto our original net. The only thing we need to figure out is what our X is. So if we figure out the x there, if you figure out what x is, we know to find the area of our rectangle is length times width. We can figure out, so length times width for each rectangle. Careful that you're using the correct width. They are not all the same. Notice if you labeled your net correctly, your widths are not all the same. So once you solve for x, you can find the area of the rectangles then.
What I meant by doing that was the 960 times 2 was to take out the 1/2 from the equation. So it's just
Okay.
like
So when you skip process, I don't quite follow. So we have to start with the original equation and then walk through how we're getting there. Otherwise, it confuses us. So you were on the right track. You just didn't tell us how you got to that point. So when we're explaining how we're doing something, you always want to start at the beginning so other people can see where you started from. Okay? Does that make sense? Are you guys seeing how to do that?
No.
Okay, so do we understand how we got the numbers on our net? Yeah? How when we flattened out the net, that's where all the numbers went. This is where our x is. So to find, if we know the volume and we know that is our formula for the volume of a triangular prism. We need to fill in the numbers that we know. Colin?
I noticed when I added it all up, I didn't match what it says in geometry.
What do you mean what it says in geometry? Yeah, theirs is different. They're not doing the same volume. So it's not going to match. They were given a different number. It's not building off of each other. It's completely separate. Okay, so it's not going to match with geometry. And that's okay. They're given different numbers to work with, so theirs is different.
Wait.
Otherwise they wouldn't have to do any math. They would just look up and say, oh, the volume's 960, done. But they have to do math themselves. So he did not make it that easy for geometry. So when you get up into geometry and you get something like this, it is never that easy. Okay?
And then we could just
All right, so let's look at, oh yeah, and otherwise you would just say it's 756. It's not that easy for you either. All right, so this is our formula. We're going to fill in the numbers that we know. 960 is our volume. 1/2 times x times our width of 12 times the height of 8. So 960 equals 1/2 x times, what's 12 times 8?
96.
What's a half of 96?
40.
Maddie, do you see how we got that? We're just doing our math. 12 times 8 is 96. 1/2 of 96 is 48. Still times x. Now we need to solve for x. So do the opposite. What do we have to do if we're doing the opposite? Divide, because we're multiplying 48 times x. If we want x by itself, we have to divide by 48 then. So that will give you your x to fill in here. All right. Let's see how well we remember our formulas. Who can tell me what's the formula of a rectangular prism? Say it out loud. Length times width times height. What's the formula of a cube?
Side times 3.
Not side times 3.
Side cube.
Side cubed. You gotta say it the correct way, because if you say side times 3, then it would be 9 times 3, and that's not it. When it's cubed, it's that number multiplied by itself. Last packet, our volume was 27. It was not 9 times 9 times 9. Okay? Because that wouldn't give us right. What? Ah, yeah. It was 3 times 3 times 3 got us to the 27. So you have to make sure I don't ever put length times width times height for the formula for a cube, because I want to remember it has to be the same number for each of those numbers, each of the measurements. It has to be the same. What is our formula for the triangular prism? We just talked about it. 1/2 length times width times the height. What is our formula for our pyramid?
Length times width times height divided by 3.
So it would be 1/3 or divided by 3. So because it's that pyramid, instead of dividing by 2 like we did for the triangular prism, this time we divide by 3. What is our formula for our cylinder? Say it louder. Somebody said pi times what? We start out with our circle, pi r squared times the height. Pi r squared times the height. So I always start with that circle. So our cone, we have our circle. So what do I start with?
Pi r squared times slant.
Not a slant. That's for surface area. Pi r squared times the height, but that's what I did for the cylinder. So what do I have to do for a cone, because I'm taking out of the cylinder? Andrea? Divide it by 3. Okay, just like with our pyramid, we divided by 3. With the cone, we divide by 3. Andrea? Do you know the sphere? Tell it to me.
Pi and there's the number 4.
Oh, I know.
Paul.
4/3 pi r squared, right? No.
Super close. 4/3 pi r. The square is if it's a circle.
Oh, cube.
Cubed for a sphere. 4/3 of pi r cubed. So now pre-algebra only has to do 3. We're preparing for the math test. We're preparing to show Mr. Schultz how much we know. Challenge yourself. Go above and beyond the 3. Challenge yourself. Seriously, friends. Challenge yourself. It's not what bare minimum can I do. That doesn't help us learn and grow. Challenge. Oh, Fibonacci numbers. Woo. And listen for this one. The composition of a number describes how the number is made up, or put another way, how it is formed. The Fibonacci sequence can be used to determine how many ways a positive integer can be written as the sum of 1s and 2s. To help us, we use the table below. This table displays the Fibonacci numbers as well as its position in the sequence. So the F is for Fibonacci. The first Fibonacci number is 1. The second Fibonacci number is 1. The third Fibonacci number is 2. The fourth Fibonacci number is 3. Okay, so the seventh Fibonacci number is 13. The number of compositions using 1s and 2s for a positive integer n is the Fibonacci n plus 1. So, for example, to find the number of compositions for n equals 4, we look to the Fibonacci 4 plus 1. So that would be the Fibonacci 5. So there are 5 compositions of 1s and 2s to get us to equal 4. So there are 5 compositions. It's important to know how many sequences you need to do to find them all. Okay, so let's do a few together. It took me a minute and a question to Mr. Schultz to know how to do this. It's not the easiest. Okay, so I'm going to help us with that. Hello. Okay. Perfect, because I hadn't told him he was bus yet, so that works. Yay, thank you. All right, bye. So, Owen, just so you know, you switched from car line to bus, but now you're back to car line.
Yes.
So you're all good.
Yes.
Okay. If we're doing the composition using 1s and 2s for n equals 5, we're going to use 1s and 2s to equal 5. So, if I'm doing just 1s, it would be 1 plus 1 plus 1 plus 1 plus 1. That gets me 5. That's my first composition that I'm going to do. How many compositions am I going to come up with of 1s and 2s? I heard Colin say 6. How did you come up with 6? So our Fibonacci, it would be Fibonacci of n plus 1. So it would be the Fibonacci 6. But what is my number for Fibonacci 6? So I am going to have 8 different compositions. So this was my first one. I'm going to have a second, a third, a fourth, a fifth, a sixth, a seventh, and an eighth. I'm going to have 8 different combinations to come up with. Their placement of the 1s and 2s matter. So I could do 1 plus 1 plus 1 plus 2. So instead of having 2 1s, now I'm going to have a 2. That's a second combination of 1s and 2s. I can put that 2 in a different place, have 1s before, 1s after it, and that would be another one. Cool.
So you can use you can do 1 plus 1 plus 1 plus 2. So you could do that combination, but can you do it?
You can switch it around. 1 plus 1 plus 2 plus 1.
So that would be.
That's another combination.
Oh, okay.
You have to find all 8 for this first one. How many do we have to find for our second one?
13.
How did you figure that out?
It's 6 plus 1, which equals 7, which is 13.
Our n was 6 plus 1 gives me 7. My Fibonacci 7 equals 13. So there are 13 combinations of 1s and 2s. You have to figure out all the different orders of the 1s and 2s, 13 of them. So you have to find all 8 for the first one and all 13 for the second one. In order to get full credit, you need to find all the combinations. You can do it once you know how to do it. Polynomials we know. Oh, let me put this down so I can actually move up. Polynomials you know how to do. Logic. This is like playing Sudoku. If you guys have ever played, how many of us have played Sudoku? Okay. Yeah, a lot of us have played it. This is an easy one. There's only 4 in each square. Usually it goes up to 9. This is easier. So you're going to have in each row, in each column, in each square, you're going to have 1, 2, 3, 4. No duplicates in a row, no duplicates in a column, no duplicates in a square. Easiest one to start with. I have a 2, a 3, and a 4. What's going to go in my empty box? Okay. Start filling them in, the ones that you can figure out. We have a 1 and a 4 missing on the top row. How can I easily figure out what goes where, Chase?
There's a 4 in the column all the way on the right, so there has to be a 1 up top.
There's a 4 already here, so we can't put the 4 up here. We have to put the 1 up there because we can't have 2 4s in the same column. So if we have to put the 1 there, we know the 4 goes there. So figure out logically where the 1s, 2s, 3s, and 4s go. So there's no duplicates in a row, there's no duplicates in a column, and there's no duplicates in the square. And with that, I'm going to say goodbye to our friends at home. We hope you are well, and we hope to see you soon.